CPU bound means a task or program is limited by how fast the computer's brain, the CPU, can work. If you make the CPU faster, the task finishes faster. To understand this, imagine a chef making sandwiches. If the chef is slow, sandwiches are made slowly, even if there are lots of ingredients ready. Making sandwiches in this case is chef-bound. The speed depends on the chef. In computers, the CPU is like the chef. If the CPU is busy doing lots of calculations, the whole process waits for it to finish. There are many real-world examples of CPU-bound tasks. For instance, video editing often requires applying effects to a video. This needs lots of calculations. The faster the CPU, the quicker the video is processed. In gaming, some games use the CPU to calculate game logic, physics, and artificial intelligence. If the CPU is slow, the game can't run faster, even if the graphics card is powerful. Another example is calculating digits of pi, which is just number crunching. The more powerful the CPU, the faster you get results. CPU-bound tasks spend most of their time doing calculations. They don't wait for data from the disk or the internet. If you want these tasks to go faster, you need a better CPU, not a faster hard drive or internet connection. When a program is CPU-bound, the CPU is working at or near 100% usage. To quickly compare, CPU-bound tasks are limited by CPU speed, such as video editing or calculations. I/O-bound tasks are limited by disk or internet speed, such as downloading files. Another way to think about it is to imagine a factory. If the assembly line, which represents the CPU, is slow, products are made slowly, even if there are plenty of parts or data. Speeding up the assembly line speeds up the whole factory. In summary, a CPU-bound task is like a chef who can only make sandwiches as fast as they can move. No matter how many ingredients you have, the chef's speed is the limit. In computers, if the CPU is the slowest part, it sets the pace for the whole task.